Now, part B says, what is the probability that the next customer comes in the next 30 seconds? So that's probability that X will be less than or equal to half of a minute, 0.5, 30 seconds. So that's 1 minus e to the negative 0.5 times 0.4, which is 1 minus this term, e term that I'm going to compute for you now. So clear out 0.5 negative times 0.4 equals second function natural log, and we get 0.8187. 0.8187. So 1 minus 0.8187 is 0.1813. So the probability that the wait time, or I'm sorry, arrival times will be less than half a minute or 30 seconds is right here. So that's the final answer to this part. Now for the next problem, part C, we want to know what's the probability of customer arriving in the next 15 minutes. So probability that X is less than or equal to 15 minutes. Here's 15, and this is what we're looking for. Again, using our 1 minus e negative 15 to the power of 0.4, we get let me put this here, 15 negative times 0.4 equals second function natural log, which is 0.0025, but I want to subtract that from 1, and I get 0.9975. 1 minus 0.0025, which is 0.9975. So this area right here is 0.9975, which answers my question. Okay, the next question is, what is the probability that the customer arrives after 10 minutes? Oops, I got rid of it. File, edit, undo, erase. Okay, so I want probability of after 10 minutes. So probability that X is greater than or equal to 10 minutes is what we're after right now, which is this area right here. This is what we're looking for after 10 minutes. Okay, so probability of that is 1 minus probability that X is less than 10 minutes, right? Because this area we know is the probability that X is less than 10 minutes. And because the total probability under the curve, area under the curve must equal 1, then this black shaded area will have to be 1 minus the pink area. So by definition, we already know what this area, how this area can be computed. That is P less than or equal to negative 10 is 1 minus e to the negative 10 times 0.4. So 1 minus that will give us the answer. But notice we have 1 minus 1 minus an e term. So in this situation, the 1 minus 1 minus essentially cancel out. So we can find the answer to this part by just computing the e term. So using the calculator, I get 10 negative times 0.4 times 0.4 equals negative 4. Second function, natural log, and that gives me 0.0183. So e to the negative 10 times 0.4 is equal to, this is the area that I was after. This is equal to 0.0183. Okay, and finally, the last part said, what is the probability that the customer will arrive in the next 12 to 15 minutes? So probability that x is greater than or equal to 12 or greater than or equal to 15 is what I'm after. And graphically, it's going to be 12 here, 15 here, and this is what I'm after. So if I can find, using my basic formula that I have, if I can find the probability of less than 15 and the probability of less than 12, then and subtract the two, then I have this area which I'm interested in, which is this area right here, which answers this question. So the plan is find probability that x is less than or equal to 15, subtract from it probability that x is less than or equal to 12, and that will give me the answer to this problem that I'm after. So probability of x being less than or equal to 15 is 1 minus e to the negative 15 times 0.4 minus probability that x is less than 12, so 1 minus e to the negative 12 times 0.4. And by going through the same computations that I did before, and I'm not going to repeat it, I'll let that be your practice. You should find probability, and I don't think I've done it, so I may have to repeat it here. X less than or equal to 15, I think we computed just right now. Yeah, x less than or equal to 15 we found here to be 0.9975. So I can use that, 0.9975. Less than or equal to 12, I can compute using my calculator, 12 negative times 12 negative times 0.4 is equal to that second function, natural log, and then I'm going to make it into a negative and add 1 to it, and I get 0.9918, 0.9918. So the difference between the two should be 0.0057. So this area is 0.0057, and that is the answer to this problem. So there is almost a 6 in 1,000 chance that a customer will arrive exactly between 12 minutes to 15 minutes. Now, again, as a reminder, whether I had said probability that customer arrival time is greater than 12 and less than 15, or whether I say probability that X is greater than or equal to 12 or less than or equal to 15, both of these will be equal because exponential distribution is a continuous distribution, and such random variables will have a probability of 0 for an exact value.